This LED brightness is controlled by this potentiometer. When I turn this LED at this potentiometer, the LED start to brighten up until it reach the maximum brightness. And when I turn the opposite direction, the LED will start to fading out until it fully turn off. So this video will discuss on how we can do this, how we can control this brightness, the brightness of the LED or any outputs by using an analog sensors or this potentiometer. So before we move further, let us first understand how the analog signals and digital signals is differs. So let's look at this example of these two waveforms here. One is digital sensors or digital signals and another one is analog signals. So the blue one here is the analog signals and this is digital signals. As you can see here, these digital signals only have values 0, and when it goes high, it directly goes to 5 volts. There is no values in between 5 and 0. It only goes back, and after 5 it will goes back to 0. So this is digital, discrete signals. And now we look at this analog signals. If we look at this analog signals, at every time, at every seconds here, we can see that it has different values here. So here has different values and here also has different values. So this might be around 4.2, maybe this is about 3.2, and this is about 1.7, and so on. So for this time span here, we can have various values of signals, various values of data. Compared to these digital signals, every parts of the times here of this period here, signals period here, is only giving this either 0 or high, which is 5 volts. So it is either 0 or 5 volts only. And this is how the difference between the analog signals and the digital signals. To read these analog signals here, we need to first convert these analog signals into digital signals. And this is why if we look at this Arduino here, there are 6 analog ports here, A0 until A5. And in these analog ports here, there are this what we call the analog to digital converter, or the ADC. So how this ADC works? So this ADC works is basically it takes this analog signals here, analog curves here, for example. So this is the analog signals, which it will convert it into the digital signals here. So as you can see, it becomes this steps graph instead of curves. Why? Because this is converted into only, it can only save into this 8 data only, 0, 0.625. It cannot save every data of this curve because we only limit it to 8 data only, which means if we say this is 8 data, and if we want to know how many bits it is, so the n bits is basically 2 power of n data. So now we have 8 data, which means the 2 power of n is equals to 8. So 2 power of n is equals to 8 data. So if you want to know the n values, we will use log 8 over log 2, which we will get 3 bits of data. So this is basically, this data here is only be stored in 3 bits only. What does it mean by 3 bits? It means that this first value here is stored in 0, 0, 0, 3 bits. 1, this is 1, 2, 3 bits. So this second value might be 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 101, 110, and finally 111. So it only have this 8 datas only. And because of that, this each data here is representing this value here. 001 is basically the 0.625 in decimal. 010 is basically 1.250. So which means this binary data here is representing this value here, 000, and then 010, and so on until 111. So each of this binary data is representing this decimal places value, and because it only can store in these 8 values only, so any values that closer to these decimal places will only be converted into, or will be rounded into, the nearest value, nearest binary values. And that's why we have this steps shaped graph here. So this is basically if we have an example of 3 bits data only. So if we increase the bits or increase the values of binary data, for example like this one here, which we start to see it becoming much more, almost closer to the original curve, because now it can store more data. So this might be if we increase into the 5 bits, for example. So 5 bits, if we try to calculate 2 power of 5s, so 2 power of 5s, we get 32 data. So we'll get 32 data here, which is more than just 8 data in the previous example here. So this is why again we get a much more closer values compared to the analog signals here. So if we increase further to 6 bits, 8 bits, and finally up to 10 bits, it will have, for example, if we have 10 bits, so 10 bits, we have 2 power of 10, which is equals to 1024 data, which means that in between this, in between 5 to 0 volts here, there are 1024 data. That's why it can becomes a more smooth curves than the previous values, and this is also why this ADC for this Arduino here have a 10 bits ADC. It is in 10 bits, not in 5 bits, not in 3 bits, because it wants to reproduce back the curve as smooth as possible, as original curve, as analog signals as possible. And this is the basic of how we convert these analog signals here into the digital signals. So which means that every decimal values here has its own digital representative, binary representative of each of these value, which up to 1024 different binary data. So again, this is the basic concept of analog to digital conversion. Now we know how a basic of analog to digital conversion is done, and now let's move on to our circuit. As usual, we directly go to our circuit, so you can start to construct this circuit here, by adding this potentiometer at the A5, at the A5 ports. So you can pause this video as usual, for you to start to construct this video before you continue with the next part. So this is basically the same circuits as before. We have this PWM circuits before, which connected to the pin 11, and now I just want you to construct this circuit by adding this one potentiometer, which one terminal potentiometer doesn't have polarity, so you can just use any terminal for you to any of these two terminal. One must be connected to the ground and one more is connected to the 5 volts here. So this is you can take this time to construct this circuit here, or again, if you don't have any hardware with you, so you can go to this Proteus as usual. Now again, this is the same circuits that I used in the PWM tutorial before, and I just add this potentiometer here. This potentiometer here with the VCC and also ground. So that's it, that I connect to the A5 ports. So make sure you choose the potentiometer. When you search for the potentiometer, it will come up with a lot of choices here. Don't choose the other one, choose this one, port HG, port dash HG active. Why active? Because we want to simulate the changes of values. If we just choose a normal the other potentiometer, we cannot simulate the differences of this value. So again, make sure you choose this port HG here if you want to use for Arduino for your simulations. So again, why it is connected like this, so we want to know this, we want to change this V values here, the V out here. So again, this is similar to the voltage divider circuit. So voltage divider circuits, which we have this R2, and then this is the V out, and then R1, and then this is the VCC, the 5 volts. And this V out here, if we want to calculate it, it's just simply, this is the VCC. We can just simply calculate this by using the voltage divider formula, the R2 over R1 plus R2 times with the VCC. So this is basically what we need to do. This is what the potentiometer do. It changes the ratio between R2 and R1. So when it changes these two ratio here, what happens is the voltage, the V out voltage that will comes into the A5 will change from the lower until the maximum voltage. So if we what we give in the hardware is basically, what I use in this hardware is basically 1 kilo ohms. So 1 kilo ohms potentiometer, which means the maximum resistance is 1 kilo ohms, and we will change the ratio between it. And here also you can change the value to 1 kilo ohms. So this is how the hardware is constructed. For those who have the hardware, you can follow this circuit here. You can pause this video and follow this circuit, construct your circuit now. And for those who don't have hardware, you can follow this circuit. Again, you can pause this circuit and construct your circuit now before you continue with the next parts of this video. So now, after you have construct your circuit, whether in the Proteus or in the hardware, so we can continue with the coding. So as usual, open up your Arduino IDE here. We can continue with our coding here. Before we move on, let's first we define a variable, a constant first, like in the previous video. So let's define it globally so that it can be used in all the functions that we will use after this. So we just define a constant. So again, constant, which is in integer, potentiometer, just put, or if you want to put a full name, just put a full name there, which is again in the pin 5, number 5 here. So which means that here we put 5 for the potentiometer pins. One more tips, if you don't know yet, If you already know, just assume this is as a reminder, as a recall. Anything, if you don't want to confuse, or if you works in groups especially, yes, so that everyone in your groups understand your coding, make sure you put these command lines here, with this double slash here. So this double slash means the coding will not read these lines, but only for your nodes only. So if you want to put any nodes, you can put it as double slash, or maybe you can also put it as slash star. Yeah, so if you put slash star, it will directly comment out everything until you put another star slash, so it will stop the comment. So now the only programs that will be read by our Arduino is this part here. This part here will not be read by the system. So if you don't want to put double slash in every lines, this is the way for you to do it. But if you just have one line to command, then just put double slash here. So as simple as that. Now we continue with the next lines of course, which we can add values that we read from the analog pins. So the values, which is, since it is in ADC again, in digital, from 0 until 1024 1024, because it is 10 bits, so which means that it is in integer. So it is in integer. Value start with 0. So if you don't want to put a long names there, so you can just use val or whatever. So let's say value equals to 0, so start with 0 value. Okay, so now we move to the void setup. So in the void setup, we don't put anything, we just use one lines here, the new informations for you here if you never used Arduino before, which we will use this command here, serial dot begin, which is we then in this columns here we put 9600. What does this mean is it will start the serial monitoring with a baud rate of 9600 baud rate. So this is to start your serial monitoring, which I will show later. So this is for serial monitoring. And then now we go to the void loop. So that's it for in the void setup. So now we go to the void loop. So in this void loop here, we have already initialized the value, or we already have defined the value up here. Yeah, so now if you don't define it, you just put again what kind of variable it is, either integer int, if it's a character then char, and so on. So you can find it in the notes for the whole variable definitions, or maybe you can recall back your C programming class for the whole variable definition. So now if we have integer here, so we just add integer here, which is the value will be read from, so that's why it use analog read from the potentiometer, because we have defined potentiometer here. Let's say you don't define it here, therefore you put the pin number inside this brackets, so you put 5 there, but because we already have defined before this void setup here, and that's why I put here as potentiometer port. So that's it, which means we want to ask our program to read data from the potentiometer first, and then after it reads this data, it needs to display this data in the serial monitoring. So again, since it will display this data in serial monitoring, so we use serial again, but display, it will print this data, so serial print Yeah. And then what data? The value of analog read, so the value. Okay, so as usual at the end you must put this semicolon. And finally, before it start to read another value, we put this delay. Yeah. So it's up to you how long you want to wait. So for me, I just put it here 1 second. Yeah. So again, 1 second, 1000 millisecond. This value here is in millisecond. So 1 second is 1000, and that's it. That's it. That's how the coding does. How to read the values from the analog ports. Yeah. So this is the only lines actually. Yeah. The other lines is basically on how to display in serial monitoring. So now let's check our code as usual. Save it in whatever name you want to name it. So after you save, compile, done compiling. So when you're done compiling, so now we can try to run it. As usual, before run, check your board is correct, your COM ports is correct, and then after that just click upload. If everything is okay, just click upload. Done compiling. So let's test with our hardware, and before that we look at, because we want to display in serial monitoring, so we don't have any LCD or whatever there. So go to this part here. Look at these symbols here, magnifying glass symbols here, and click it. It says serial monitoring, so click it. So now you can look at these values here. It has that value there, which keep changing there. This is if we change the value on the potentiometer, it will change, but it all is in one line. So this is not nice. So because of it is too confusing because everything is in one line. So let's stop the coding first, and we change this. Instead of using serial print, we use serial print line, LN. We add these two characters there, serial print line. So what does this serial print line does? Before this, it just print everything in one line. So when it says serial print line, when it repeat this loop, it will print at another row, and then when it repeats again, it will print another row. So it will continue downwards. So if we start to upload again, and now let's retest this code. So when we change this potentiometer value, we turn it around. So now as you can see, the values display in one, every data is in one line, so it will display nicer than before. So if we turn it until the end, until it reach the ground value, so it becomes 0, because this part here is ground, so it becomes 0. And when we go to the 5 volts again, because it is work as voltage divider, so if we increase it until the 5 volts here, so it will go to the maximum value, which is almost reach the 1024. So again, which means that it is in 10 bits, because we have seen in this notes here, if 1024 data is collected, meaning that it is 10 bits, and this means that this ADC here is in 10 bits. So if you don't have hardware, this can also be done in this Tinkercad here, by writing the codes, or copy and paste the codes into this code parts here, and then start simulation, and then you can open the serial monitor here. So if you open the serial monitor here, see it will comes out with this information here, and you can change the potentiometer, and as you can see, the values in the serial monitor is also changing. So you can play around with this potentiometer value here. So that's it. That is if you don't have hardware with you. So I think that's it for this time around. So as usual, if you have problems, if you confused, if you don't understand any parts, so as usual, you may ask me. Please ask me. Don't be shy. Just ask privately or in the group message anywhere. Yeah, or just comment down below. Don't worry, I will reply to your comment. I will answer it. And as usual, if you like this video, hit the like button and subscribe. Don't forget to subscribe. And that's it for me. I'm Ikhwan. May God bless you. Assalamualaikum.